Okay, in this video, I'm going to go through our note from class on applying linear systems to solve real-world problems. You probably use linear equations to solve kind of real-life problems in grade 9. The difference in this course is we're going to solve problems where we're trying to find out two unknown variables at once, right? So we've been talking about linear systems. We need to find x and y. So it's going to be useful when we need to solve for two quantities at the same time. So, for example, in this first question, Steph has 5 more fish than Brett. They have a total of 31 fish. We're trying to find out two things. We're trying to find how many fish does Stephanie have, how many fish does Brett have. So the two things that we're looking for are going to be our two variables. So I could let S represent the number of fish that Steph has. And I would pick your variables carefully. So I'm calling it S for Steph. S can be a little bit risky because if I'm not careful, it's going to turn into a 5. You can always use X and Y. And then we can let B represent the number of fish that Brett has. So anytime we have a word problem, we want to define our variables first. That's going to help us at the end to write our concluding statement. So let B represent the number of fish that Brett has. And my goal here is to translate each of these two sentences into a mathematical equation. So Steph has 5 more fish than Brett. That means, first of all, we know that S is going to be bigger than B, and we know it's going to be 5 bigger. So my first equation, S is going to equal B plus 5, right? So Steph has 5 more than Brett, or S equals B plus 5. I'm going to call that equation 1. And then the two of them together, so S and B together, is a total of 31. So I have S plus B equals 31. So this is definitely the most challenging part of the problem, is making our two equations. The easy part is actually solving. You can pick whatever you think will work better, elimination or substitution. In this case, S is already isolated in 1, so I think substitution makes sense. So I'm going to sub 1 into 2. So I'm going to take this expression for S and use that to replace S in my second equation. So I've got B plus 5 replaces S, and the rest of the equation I just copy down. Equals 31. So I've got 2B, or not to be, nope, just 2B plus 5. Going to move the 5 to the other side, so I'm going to subtract it. So I have 2B equals 26, or B equals 13 after I divide by 2. As always, when I'm solving a system of equations, I need to have two quantities or two variables, right? I need X and Y, or in this case, I need B and S. So I'm going to sub B equals 13 into either equation. Equation 1 looks a little bit easier. I mean, they're both pretty easy in this case. So I've got S equals 13 plus 5, so S equals 18. So just like always, I need to solve for both variables. And this is the one time in this unit where we're not going to write the P of Y is. Instead, we're going to write a concluding statement that makes sense in the context of our problem. Well, what do S and B represent? Well, S was the number of fish of Stephanie. So I could say Steph has 18 fish and Brett has 13. So we want our therefore statement to kind of connect back to the problem. So the challenge here is we're going to start with English. We're going to translate it into mathematical equations. We're going to solve the equations using our pick of substitution and elimination. We're going to translate back from math into English. So I kind of like think of math as a language that we can translate into or out of. Defining the variables carefully is really going to help us both in building the equations and in writing that final concluding statement. Let's do a couple more examples. There are 296 tickets sold for the school banquet. Adult tickets cost 10, student tickets cost 5. Let me refocus my camera. The receipts total 1910. So receipts just mean revenue, like we earned 1910. How many adult and student tickets were sold? So we immediately can think, well, the two quantities I want are adult tickets, so why don't we let A represent the number of adult tickets? So it's good to be kind of specific. So A is the number of adult tickets. If I just said A represents adult tickets, well, do I mean the price? Do I mean the quantity? So number makes it really clear. The other thing I want to know is how many student tickets. So let S represent the number of student tickets. And again, I want to create two equations from these two sentences. So there were 296 tickets sold. So altogether, A plus S equals 296. That's equation 1. And then the second equation is going to have to do with the money. So each adult ticket costs $10. So the total I raised from the adult tickets will be 10 times A, however many I sell. So for example, if I sold 17, I would make 10 times 17, $170. And then 5 times S is the money I raised from my student tickets. And altogether, that equals 1910. So often in these questions with money or with prices, I'm going to have the first equation is going to be like the quantity equation. It's going to deal with the number of items. And then the second equation is going to deal with the value of those items. Then I could solve with elimination or substitution. You pick. So I could rearrange this pretty quickly to use substitution, but they're also already nicely lined up. So why don't I multiply equation 1 by 10? Because then I'm going to have equal coefficients on my A variable. And then I can subtract. Whenever I have equal coefficients, I can eliminate by subtracting. So I'm going to do 1 minus 2. So 10A minus 10A is nothing. 10S minus 5S is 5S. 2960 minus 1910 is 1050. Then if I divide by 5, that means I've sold 210 student tickets. Again, I'm only halfway done the problem. I'm going to sub S equals 210. Equation 1 looks like some lower numbers. I like low numbers. So I've got A plus 210 equals 296. So A equals 86. And then again, your therefore statement, you can always connect back to your let statement. So A was 86. What was A? The number of adult tickets. So 86 adult tickets and 210 student tickets were sold. So again, we always want to kind of follow these same steps. I want let statements. I want to set up equations using all the information from the problem. And then I want to solve. This time I used elimination. And 210 student tickets were sold. And then I want to write some kind of concluding statement. The more you do these questions, so the challenge with word problems often, how do I get started? What are my equations? You should kind of look for patterns and types of questions that will kind of appear again and again on our practice, on your test. And if you can connect different types of questions back to the examples, I think that can be really valuable. So the next two types, we're going to do an investment type and then a chemistry type. So this is kind of a business application. So when you invest money, you earn interest. So the way that works is if you put $1,000 in the bank and the interest is 5% per year, at the end of the year, the bank is going to give you 5% of your investment, and that's called interest. So Mike's investing $8,000 into two accounts. One account is paying 9% per year, and the other account is paying 12% a year. If you're saving money, you want higher interest. One account's better, but for whatever reason, he's splitting up his money. So we can say, let X represent the amount in dollars. It's always nice to include our units. So let X represent the amount in dollars that Mike invests at 9%. So that's how much he's putting into that first account. And then the rest of his money, let's call that Y. That's going to represent, I'm using ditto marks, I'm writing the same thing. And this is fine if you want to do this as well. Just save yourself some time in writing. These ditto marks means same as above. So let Y represent the amount in dollars that Mike invests at 12%. So altogether, he's investing $8,000. So whatever he invests in the first account plus whatever he invests in the second account is going to equal a total of 8,000. So that's equation 1. You can think of that as being the total money. So that's kind of the total invested. And then the second equation is going to deal with, well, how much interest is he really earning? So on however many dollars he puts in the first account, he's going to get 9% of that as interest. So first of all, I'm going to convert the percent to a decimal. 9% is 0.09. So 0.09 times x will be the interest from the first account. So if he invested $100, if x was 100, he'd earn $9 in interest. He'll earn a little bit more. Whatever y is, he'll earn 12% of that, so 0.12 times y. And then his total interest was 810. So we can call that equation 2. We call that the interest equation. So I've got the total invested equation, and I've got the interest equation. And then again, I could solve this with substitution or elimination. So it's pretty easy to isolate for x or y. I could use substitution. I could also use elimination. One piece of advice is if you don't like dealing with decimals, I could just write at the start of the question, multiply everything in equation 2 by 100 to get rid of the decimals, if that helps you solve. So I'm not going to solve it here in this video. I do have the solution to this uploaded on our Brightspace page, but you could use substitution or elimination to solve for the amounts to be invested at each rate. And again, if you carefully set up the let statements, it's going to make that therefore statement a little bit easier. Because then I can say, okay, well, I figured out, let's say x is 5,000. I don't think it is. And you can say, well, 5,000 is the amount of dollars that Mike invests at 9%. So writing careful let statements helps you set up the equations. It also helps you draw a nice conclusion. The last type of problem we're going to look at is a bit of a chemistry problem. So you can ask, I don't know if you're taking science this quad, you can ask if your science actually have to do this. So we're trying to mix acid for an experiment. So for the experiment, we need 8% acetic acid, and we need 250 mil of it. Now, the problem is we don't have acid at every single percentage in our chemistry storeroom. I don't have a bottle of 8% acid, and I also don't have a bottle of 100% acid because that'd be too dangerous to have in a school. Right? I don't know what acetic acid is, but maybe 100% acetic acid is dangerous. So instead, I've got some 5% acid and some 10% acid, and I want to pour some 5% acid and some 10% acid into this measuring cup, and I want to fill this up, so I'm going to get 250 mil, and 8% of that solution is acid. So what 5% acid means is in this bottle, I've got 5% pure acid and 95% water. And same with the 10%. So how much of each should we use? So why don't we say let x represent the amount. Again, we want to be careful with units, so I can say the amount in milliliters of 5% acid. So it's how much am I pouring from this first bottle? And then why don't we let y represent the amount in milliliters of 10% acid. So altogether, I take x from the first bottle and I take y from the second bottle. I'm going to get 250 total mil of solution. So we can call that, let's call that equation 1. It's always good to label our equations. But we can always call that, maybe we'll call that the total liquid equation. The second equation is going to deal with, well, how much pure acid is in there. So however many milliliters of X I pour in, 5% of that number is going to be the pure acid. So if I pour in 100 mil from X, 5 mil is going to be, pure acetic acid. Same thing, 10% of Y. So if I pour in 200 milliliters of Y, 10% or 20 milliliters of that is going to be pure acetic acid. Remember to convert percent to the decimal. Well, how much pure acid do I want in total? Well, I want 8% of 250, which is the same as saying 0.08 times 250. Okay. So again, I've got two equations with two unknowns. So I've got a system that I want to solve, label that equation 2. And again, if you want to get rid of decimals, you could right away multiply equation 2 by 100. So I'm going to multiply equation 2 by 100. So now I've got 5x plus 10y equals 8 times 250. I know that 8 times 250 is 2,000. So now I've got two equations with integers, which we prefer. And then again, I could use substitution or elimination to solve. So the hard part is kind of defining a variable, setting up the equations. This should be the part that we're more comfortable with. It's going to be a pretty straightforward. I could either multiply equation 1 by 5 and use substitution, or I could move the y to the other side and then substitute the expression in for x. We could use either substitution or elimination to solve for x and y, and then I'd write my concluding statement. Again, I'm not going to go through that in the video, but the full solution is available up on our course Brightspace. Okay, thanks for watching. You've got some practice problems to do with word problems, and you might notice that these will all line up with sort of the types that we've done in these examples. So again, let me know if you have any questions, and thanks for watching.